triangular inequality, that is z1 plus z2, its absolute value is less than or equal to the sum of two absolute values. Triangular means that if we have this is z1, this is z2, then this is in fact z1 plus z2, okay, then the absolute value of this is obviously it is less than sum of these two. It is equal only when they lie on the same line over here. If this is z2 over here, then this equal this one. We can prove it very easily. This square, by definition, it is using this over here. This square is equal to the product of complex number and its conjugate. So this square means the product of this number and its conjugate, right? So we can use this another property over here, that the conjugate of the sum is sum of the conjugate. Okay, so we can multiply just multiplying these two terms, then we can see over here, this is again z1 mod square. Here we can write this z1, z2 conjugate, and we can write z2 conjugate and then whole conjugate. This is conjugate of conjugate will give you this same result. So if you consider this one number, this is complex number, and this is its conjugate, then using the property that complex number added to its conjugate gives us twice real of the complex number. So this is equal to twice real of z1 z2 conjugate. Okay, this is a complete. If you consider this is one number, then its conjugate is this one. This is a number, and its conjugate is that one. So x plus this is z plus z conjugate gives twice real of z. So it is twice real of z1 z2 conjugate. This one? z1 into z1 conjugate, z1 conjugate, by this definition. Okay. So similarly, z2 into z2 conjugate, by this definition, again we can write in this way. Again we can use this over here, that look at this, real of z is less than or equal to the magnitude value of real of z. So that means if we replace this with this, we replace this with this, then the whole thing will be less than. Okay, so this inequality, this equality will be inequality over here twice real of z1 z2 and plus z2. It's okay. We are using this result over here, that real of z is less than this. So if we replace this with this, the previous thing will be less than this. Okay. Now again, real of z is less than its mod. So we are using this result again. So further it is less than or equal to Z1 square plus twice Z1 Z2 conjugate and plus Z2 square. Okay. Another thing is that Z1 Z2 conjugate is absolute value is the same as absolute value of the product. So we can separate these two, Z1 absolute value and absolute value of Z2 conjugate. So it will not change the result. So this inequality, whenever we write this equality, means the previous inequality is continuous, right? Same inequality will continue. Again, this will continue because the absolute value of the conjugate is same as absolute value of the complex number. Now look at this. We can write this as Z1 plus Z2 whole square. This square, but using the same formula, a square plus 2ab plus b square means a plus b whole square, using that formula over here. So we have this thing over here, Z1 plus Z2 its whole square is less than or equal to okay. Since this is a absolute value is always a positive non-zero quantity, this is always positive, this is also positive, so we can just take the square root and get the result. Okay, by just taking the under root both sides. So this is how this is called the triangular inequality. Another important is also Z1 minus Z2 mod is greater than or equal to this addition is less than this, whereas subtraction is greater than this one. Okay. We can prove it easily again, and